So how do we deal with an improper integral such as this one? You can look at it graphically or you can look at it algebraically. Suppose we dive into this with algebra. We can find this integral with using a u substitution. Allow u to equal this exponent. So du would equal negative 2x dx. I can get rid of this negative 2 to this side, so I have negative 1/2 du equals x dx. We can rewrite the original integral in terms of u's. So I have here negative 1 to infinity. X dx is negative 1/2 du. And of course, e stays e, but negative x squared is u. Okay. Now, the integral of, or the antiderivative of e to the u is just itself. So we have negative 1/2 e, and then u is negative x squared. All this is to be performed from negative 1 to infinity. If you want, you could do something here first. Why don't you rewrite this as negative 1 over 2e to the x squared. Yes, just using properties of exponents, equals. Now let's drop in the infinity and the negative 1, and let's see what we get from all of this. So we are looking at negative 1 over 2 times e to the square of infinity. Take away. Now let's drop in the negative 1. So something like this. But here, infinity squared is just infinity. E to the infinity is infinity. 2 times infinity is infinity. What's 1 divided by infinity? That is essentially just 0. Double negative becomes positive. The square of negative 1 is just 1. So we have 1 over 2e. So this integral not only converged, but that we were able to find the actual value of it. So that's doing this algebraically. Now, quick comment. What if we looked at this, interpreted this graphically? Recall that an integral is just the area under the curve of the picture of something like this. So I want to look at the picture of this, and I want to know what the area of it looks like from negative 1 to infinity. So here is the picture of this function. Boom, there it is. So we want to find the area from negative 1 to infinity. Well, infinity means go to the right forever. But notice that as you go to the right forever, the curve gets close to the x-axis, so it sort of settles down. Now we want the area of all of this purple region. So it would converge. The integral will converge because graphically we can see that it will work out. And algebraically we got what we got for the area under the curve. So we treat these problems case by case. You do the algebra, and then it would be a good idea to look at the graph of the integrand.